Okay, good afternoon, all.
Good afternoon, sir.
Okay, you are B17 section, right?
Yes,
Yes,
sir.
sir.
It seems you are in 18 number, 80 total class strength.
Yes, sir.
Yes, sir.
Okay, so myself, Ibrahim from EC department, assistant professor. So I will be dealing the BEEE subject for you uh, in this semester. Okay. So who are the other faculty? Do you know the names of faculty? And first of all, who is the CR?
Hello, sir. Am I audible? Good afternoon, sir.
Roll number 24, huh?
Yes, sir. 24. I am the boy CR, sir. And roll number 23, Sahiti. She is the girl CR.
23 and 24.
Yes, sir.
Okay. Uh, better you give me your numbers, mobile
Yes,
number.
sir.
Just send them in the chat, personally in the chat.
Yes, sir. Yes, sir. I'll send it.
Both names, registration numbers, and mobile numbers.
Yes, sir.
Okay, still people are joining. Only 56 people have joined. So girls here is there. Girls class representative is there. Today absent, huh?
Yes, sir. Good afternoon, sir.
Okay, okay, good afternoon. Okay, are you both from Visakhapatnam only or outside?
No, sir, I'm from Vijayanagaram.
I am from Vizag itself, sir.
Okay, okay, right. So today I will explain you. Just to start the content. I will start explaining the syllabus. Are you able to see my screen? Notes.
Yes, sir. It's visible.
Yes, sir.
Right. So our subject is BEEE, right? Uh, Basic electrical and electronics engineering. You will be learning the basic. I will be understanding the basic concepts related to electrical as well as electronics, right? In this subject. So as usual, you will have 5 modules. And the first module, we have DC circuits. And second module, DC machines. What is the third module? Yeah. Has anybody gone through the syllabus? Did anybody go through the syllabus? Next, transformers. Fourth module, um, rectifier diodes, electronics. Fourth and fifth modules are electronics. So under the fourth module, you will have diodes. The title I am not able to remember. Tell me if anyone knows the title of the fourth module. Diodes,
Semiconductors, sir.
semiconductors, I don't know, rectifiers, etc. And fifth module is
డోర్ వేసేసి లైట్ ఉంచు
fifth module is operational amplifiers. Right, and the title the 19 131, right? The title is the code 19 131. Here, am I correct?
Sir? Yes, sir. The code.
Code is correct, right?
Yes, sir. Correct.
So this is these are the units, DC circuits, and second one is DC machines, and third one is transformers. So up to this is the electrical part. The last 2 units are electronics. Okay, so you will be really enjoying the subject if you focus on this. If you just pay attention to what I'm telling, right? In the first module, for example, first of all, if you see, you will have circuits. So if you see module 1 now, you will have DC circuits. Okay, so this DC circuits will have problem solving. All every unit except 3, 4, and last 2 units, first 3 units, all the electrical part is fully problematic. Okay, so we solve problems. Okay, we will learn theories, solve problems, etc. And in electronics, it's almost mostly theory. But it has circuits to remember and practice. You have to practice the circuits, particularly the 5th module circuits. You have to practice. Okay, you will have similar types of circuits in the 5th module. Right. So this is a simple overview. Now,
Sir, sorry to interrupt. There are a few students in waiting room, it seems, sir.
I allowed all of them. No one is there in the waiting room. By the
Okay,
time
sir.
you informed me, I have allowed them.
Okay, sir. Okay. Thank you, sir.
Now, in module 1, DC circuits will have. Okay, so I think all of you have heard about or learned something about the Ohm's law, right? Am I correct?
Yes.
I think you know Ohm's law, right? Anybody can tell? Can anyone just talk about something about Ohm's law, its statement, or what it deals about? Anything like that?
Sir, it basically tells that current between the current pass between the 2 points of a wire is directly proportional to the potential difference between them.
Can you repeat once again? Once more.
So the current through the wire or any 2 points of the wire is directly proportional to the potential difference between the 2 points.
Very good, excellent. Current is proportional to voltage in what did you said, in a wire, right?
Yes,
closed circuit.
or in a conductor, mainly conductor.
Very good, conductor. That is the correct one. Conductor. Okay, so this is he. What is your name?
Dhiresh, sir. Roll number 28.
Very good. So excellently told. So in a conductor, the current passing through a conductor is directly proportional to voltage applied across the conductor. So that is what the statement. But what is the condition to be condition that should be maintained to have the proportionality working. Anybody else? Anybody? Condition.
So resistance must be.
Yes, sir.
The condition is at a constant temperature. Okay, you will have I proportional to V in a conductor. Okay, so that is the condition. So the temperature must remain a constant. Okay, so if the temperature varies with time, this will fail. The proportionality uh, fails. So current will no more be proportional to the voltage, right? So if you take a conductor, a piece of conductor. So first of all, let us see what is a conductor. Conductor. One more classification of materials is semiconductors, and third one is insulators. So electrically, this is how materials are classified. Electrically, materials are classified into three categories: conductors. First one is conductor, second one is semiconductors, third one is insulators. Okay, so these are here we are talking about conductor. The Ohm's law talks about the conductors. So when the temperature of the conductor is constant, now if you apply a voltage across the conductor, a current will flow. So as you increase the voltage, the current will increase. Okay, that is what it tells, right? So if you increase voltage across the conductor, current will proportionately increase. Okay, for example, for a conductor, when you apply a 1 volt across the conductor, then a 1 volt if causes 1 ampere, then a 2 volts will cause 2 amperes through the conductor. Okay, so that is what Ohm's law tells, right? So before that, the conductors. What are the conductors? How? What is this classification talks about? This classification talks about resistance. Resistance. So for resistors, for conductors, resistance is very less. For insulators, the resistance is very high. Resistance is very high for insulators. For conductors, resistance is very less. So for the semiconductors, it is moderate, the value of the resistance. Okay, so let us see what is this resistance actually. The resistance is nothing but resistance is opposition for the flow of electrons. It is the opposition offered by the material with which the conductor is made. So it is opposition offered by the material of the conductor for the flow of electrons through it. Okay, so it is opposition for the flow, in other words, opposition for current flow, we can say. So resistance is opposition for current flow. Okay, so after all, what is current? It is nothing but a flow of electrons. So opposition for current flow. Resistance is nothing but opposition for the current flow or movement of electrons. Right. So this is what you have to keep in mind, right? So these materials are classified like this. So conductors will have very less resistance. Semiconductors will have moderate resistance, whereas insulators have very high resistance, right? So more than 10 mega ohms. Okay, for conductors less than or equal to 1 ohm, like that. Okay, so am I audible?
Yes, sir.
Yes, sir.
So 1 less than or
Yes,
equal
sir.
to 1 ohm, so 0.5 ohm, 0.2 ohm, like that. So these values are per unit length we are talking about. Okay, or specific resistance also we can say. Specific resistance means if you take a unit cube of made up of, say, a copper material or an aluminum, which are good conductors of electricity. Unit cube, a cube if you take, then it will have between its two faces. That means cube means, I think, like you can imagine, I think. Uh, so this is a cube. Between the two faces of any two opposite faces, if you measure the resistance, right, it will have certain fixed value for a given conductor material. So for conductor copper, it is a fixed value. If you take aluminum, it is a different value, but it is a fixed one, like that. So among the conductors, you will have all the metals are conductors. Uh, all metals are conductors, right? And the best among them are silver, copper, aluminum. Gold is also a very good conductor, but for practical purposes, we don't use a silver or gold, okay, because they are very costly. Even copper is also a very costly one. So we can see copper conductors, aluminum conductors, right? Now these conductors have positive temperature coefficient of resistance. That means when temperature increases, their resistance increases. That is called positive temperature coefficient of resistance. That means if you increase the temperature of the conductor, its resistance will increase. Okay. Next, semiconductors. Semiconductors also have positive temperature coefficient. The examples of semiconductors are, what are the examples of semiconductors?
Gallium, silicon, silicon, germanium.
Silicon, germanium, carbon, okay, etc. Right. Next, if you take um, insulators, insulators are having a negative temperature coefficient amount. So with temperature increases, the resistance decreases. Oh, sorry, mistake. I told reverse. I told. So these have negative temperature coefficient. Insulators are almost fixed. They don't. Their resistance do not change much with temperature. Okay. So at very high temperatures, their resistance will change a little bit. Very high temperatures, resistance slightly decreases. Okay. So that is their simple electrical properties which will be useful, right, to learn. Okay. So up to this point, if you have any doubt, you can please ask. Do you have any doubt? Anybody, you are very free to ask doubts. and clarify your doubts. Okay. No doubt means not understood or not at all followed. No doubt.
No, sir.
No, sir.
Okay. Then okay, we'll go to conductors, right? Conductors. Conductors. I told you that at constant temperature, current flowing through them is proportional to voltage applied across them, right? For example, if you take a piece of conductor, a rectangular piece of conductor, let us take, right? So now you have connected, connected a battery by means of a wire like this. Okay. Now, because of this voltage, say a current I amperes passes through the conductor. Right? So this is conductor. Now, this current I is proportional to how much voltage you have applied here. Okay. Now, the current, the proportionality constant is 1 by R. Okay, where R is a resistance of the conductor. And this R is given by rho into L by A ohms, where rho is a specific resistance in ohm meter. L is a length of the conductor. and A is cross section area, cross sectional area of the conductor. Okay. Is it clear?
Yes, sir.
So from this expression, uh, R is equal to rho L by A, one can easily observe that from R is equal to rho L by A, we can easily say that R is proportional to length. Okay, that is, if length increases, R increases proportionately, and R is proportional to 1 by A cross sectional area. As area increases, cross sectional resistance decreases. Okay, where rho is a fixed, it is a fixed, it is a fixed constant for a given material. Okay, so R is equal to rho L by A. So this is how we can find the resistance of a material, given material, um, right? Using this formula we can find, right? If what type of material it is. For that you can search for the value of rho, right? And you can measure the length of the conductor given, and you can measure the cross sectional area of the conductor given. If it is a if it is a cylindrical or round conductor, right? You can easily find out cross sectional area by finding its radius, right? Pi r square gives you the area of cross section of the round conductor, right? If the conductor is a rectangular conductor, you can measure the width and breadth of the conductor and find the cross sectional area, and finally tell the value of the resistance of the given piece of the conductor. Okay.
Yes, sir.
So as the length of the conductor increases, right, the resistance obviously increases. So thicker conductor will have lesser resistance than thin conductors of same material. Thick conductor will have less resistance than a thin conductor when both are of same material. Okay, so that is the uh, so we have taken a piece of conductor, right? So we have applied a voltage of V across it using a cell or a say battery, right? Say a current of I amperes is flowing, then I is given by 1 by R into V. So I is equal to V by R. So this is nothing but Ohm's law only. Okay. So the its resistance or using voltage and current also can be calculated. R is equal to V by I. Okay. So in that case, you can replace this entire circuit with a simple resistor like this. This is the symbol of the resistor. Okay. So what is the voltage you have applied? What voltage you have applied? V volts. Sorry. I can represent the circuit like this. A current of I amperes. Okay. Somebody had to do. So somebody is asking about Jayant is asking about the definition of conductor. So it is not a definition of conductor. I have written here. Is it okay? Is this one you want to see, Jayant? 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 Okay, so this is a simple circuit becomes an electric circuit. So this is the simplest electrical circuit. Okay. Hello. Is anyone following?
Yes, sir.
Yes, sir.
So if I make you confused anywhere, please stop me and ask. Okay. So now and then you respond to my calls. Okay. Then only I will be assured of your focus or listening, whatever you say. Right. So
Yes, sir.
this is a simple circuit. Hmm? Now, if this is a circuit, we have entered into electric circuits. The first circuit, right? Before power, what is power? Electric power. Power we denote it with P, and its formula is V into I. It is known to you. But what is voltage and what is current? Voltage. What is voltage? What is the definition of voltage? Hmm? Voltage is always defined for a point. Okay. So voltage is always defined for a point or potential. Potential of a point is the work done in bringing unit.
Sir, can we say it as a potential difference from one point to another?
Which one?
The work done in moving a
I will
unit
tell
charge.
you. Tell you. Tell you. I will tell you.
Okay.
Say a unit positive charge is here at a distance of infinite meters, right? So the potential of this point x1 is the work done in bringing this positive charge. Work done in moving this positive charge from infinite distance to this point called x1 is the potential of this point.
Yes, sir.
So potential is always defined for a point, right? When you take another point, say x2, right? It will have its own potential in bringing a unit positive charge from the infinite distance, right? So the difference of the potentials between these 2 points is called potential difference. Okay, or voltage difference also we can say. So this is a lot of physics related. You have already studied these things, right? So I don't want to go back into them and start explaining them, right? So potential is always defined for a point. So if you want to express voltage in our circuits, we will always consider a reference point with respect to which we talk about voltage or potential of all other points. Okay, so we will always have a reference in our circuits, right? For example, if you take in this simple circuit, in the simple circuits, you observe a battery here, a cell like this. Here, this is plus and this is minus, right? Say if the potential of this battery is say 1.5 volts, we have taken a pencil which we use in our remotes or somewhere else, right? Or AAA battery or AA battery. Okay, so what is this talks about 1.5 volts? The potential difference between the 2 points, the 2 plates, potential of this plate and the small negative plate and positive plate. So the difference between these two is 1.5. Okay, so that is a potential difference. Our voltage, simply we say for a cell 1.5 volts means the potential difference between the 2 plates of the battery is 1.5 volts. Okay, so whenever you connect, if you hold the with your hand, if you hold these two terminals, terminal 1 and terminal 2 of this battery like this, okay, so it will apply a 1.5 volts across you. Okay,
Yes, sir.
right, so that is what happens. So the you are holding 2 points which are at different potentials with your two hands, right? So the potential difference will be obviously the potential difference of the 2 points. The potential that the voltage that will apply across you is nothing but the difference of the 2 points. Okay, right?
Yes, sir.
So like that, you are standing on ground, earth, right? Without any issue or any barefoot, you are standing on the ground. If you hold any power line outside of your home or somebody else, right? If you hold, wow, if you touch one phase wire, right? So the potential difference will be ground potential difference is 0, and if the line voltage is, say, if it is 230 volts, so you will have a 230 volts appearing across you, which will give you a big shock. Okay, so this potential difference, what this potential difference is nothing but like it is a force. So potential difference or voltage is like a force. What this force will do, if you apply a force on a body which is stationary, it makes it to move, right? So this potential difference or voltage, it for this force puts the electrons into motion. Okay, so that's why these electrons carry charge, that is nothing but energy. Okay, right?
Yes, sir.
Whenever electrons flow through our body, that means energy will flow through our body. If we are able to hold the energy or withstand the amount of energy that is flowing through our body, we will won't get any shock, right? So if it is our beyond our capacity, we may get shock. And if the current exceeds, if the current exceeds if current more than 20 milliamperes passes through our body, you will get a severe shock. 20 milliamperes is sufficient to cause a severe shock and be hospitalized. Okay. So
Okay, sir.
according to Ohm's law, you are having I is equal to V by R. Say here in our body, a 20 milliamperes current is flowing means so 20 milliamperes is equal to 230 volts by R. So your body resistance you can simply calculate like this. Uh, it is not body resistance, just we cannot say like that. This amount of current can give you a severe shock. Okay, so your body resistance will be of the order of mega ohms, right? So this is the general interesting things which every human being should know who generally deals with the different appliances in their homes. Okay, so it's already 2:55. I have taken 5 minutes extra, sorry. Right, we will meet in the next class. Okay, if possible, if I am feeling well. Actually I am on leave because I am tested positive for corona. So because today is first hour, I wanted to take it. Okay. You have any
Okay,
doubts?
sir.
Sir.
Huh? What?
Recover soon, sir.
Okay, sure. Thank you.
Thank you, sir.
Thank you, sir.
Sir, will we be getting these recordings in the GLAN or Moodle something?
See, actually, whether yeah, we will get the recordings. I will get a mail. In the mail, I will be given a link. Okay, so that link along with a password will come to my mail. I will try to post the link in the GLearn in our account. Okay,
Okay.
so that will
Okay.
be that video will be available for a short duration only, so you need to download if you want to keep them. And now if you want to go through the video lecture once again, you immediately download using the link password. Okay. And
Okay, sir.
also this is iPad I am using. In the iPad we have notes, right? Notes, and one app is there, in that I am writing. But how I didn't find a way to convert it into a PDF or a PPT.
Sir, there will be an option like share thing.
Sharing is done, but that is just getting a simple uh,
Or else you can just use a screenshot and take a screenshot
no,
and
no,
there
it is a
there'll be
content. See,
full
I
page
can
thing.
take the screenshot, but how many screenshots I should take?
No, sir. In the screenshot option, you have a thing like scrolling screenshot, a full page thing. If you
Okay.
if you select that, you can convert the entire thing as a PDF.
Notes means center page. It will
Sir,
be
you
like
have an
PDF
export option, na, sir.
Using that export option, I converted it, but I got some picture like very small, thinner width. That is what a
Oh,
problem here. We have to find a way. If you know something about it, then it will be very nice,
Sir,
right?
could you please share the screen now? I think I've done it before. So,
Okay, it's already time up now. People will be having
it's
another
okay.
classes, right? So let us
Thank you.
discuss in the next class. What is your name?
Balasubramanian.
Okay, Balasubramaniam. Oh, remind me in the next class. I will show you.
Sir,
Again, right? Then we will discuss and find a way to convert it into uh, a convenient document form, right?
Thank you, sir. Get well
Okay.
soon.
Okay. Bye.
Thank you, sir.
Thank you, sir.
Okay, I will end this session. Bye.
Thank you, sir.
yes, sir. Thank you.